So hello, good day. So today we are looking at this question. Okay. This is also a question that has to do with minimum and maximum points. Okay. So the question says a manufacturer wants to design an open box having a square base and a surface area of 1 square inch. What dimension will produce a box with the maximum volume? Okay. So that's to do with something that has to be maximum volume. That will give us maximum volume, a box. So this is the box. Let's say we have a box here, and then it has a square base. So this is x, is x, the square. That is the dimensions of the base, they are equal, right? While this will be referred to as the height of the box. And you know that the volume of this box is going to be the base area times height, right? So volume of box, that was, let's call it V. So that will be base area times height. So V will be equals to x squared h, right? That's the base area times height. And then in the question, we're also told that the total surface area of this particular box is an open box. Don't forget, it's an open box. So which means the surface is open, but the other sides they are closed and the base. So that's where the areas are. Which means the total surface area, hmm, let's call it S, is called the base area plus the four sides, right? Four sides. So the base area is x squared, while the four sides are what? X times h. X times h, x times h for the four sides, right? The area of the base of the sides. So that was 4xh. Okay. So from this particular question, we have been able to derive two equations that we can actually solve. So we are going to express the volume because what we are asked is to find the maximum volume, right? This is where we are going to. That is the the dimension that will produce the maximum volume. So what we are supposed to do here is to express the volume in terms of just one variable. But we can see that we have two variables here, right? Two variables in the on this side of the equation. So we will express it to have just one variable. I will now find the derivative with respect to just one variable, right? So we can do that here. We know that this one is given as 108, right? So if this one is given as 108, so we see that we can express h, for instance, h here in terms of x and substitute it in the first equation, right? So that means it will enable us to actually find the volume with respect to one of the dimensions, right? Okay, so here this is gonna be what? H, to get h from here. So that what? H will be what? 108. Let this one go to the other side. That will be 108 minus x squared all over 4x. Right? That's what it is. So here now, we'll now substitute this in this equation. And that will be what? The volume will now be x squared multiplying 108 minus x squared all over 4x. Okay? So now we have seen that from here, this is an expression of the volume and one of the dimensions of the box, right? So which is going to be when this one cos this, so that will be 108x all over 4 minus, so when this one multiplies it's minus x cubed. right? Over 4, right? Okay. So if this cost this 4 here 1, 4 here 2, 4 in 28, 7. So that will be 27x minus 1 over 4 x cubed, right? So this particular expression now is an expression of v with respect to x. We'll now find dv dx, right? We find the v dx. So for that dv dx to be maximum, then we equate it to 0, right? Just as we do for maximum points. Yeah. So for us to achieve maximum points, the v dx will be equal to 0. And to know if it is maximum, if you find the 2v the x squared, you are going to get what? A negative value. If you have negative value, it shows that this is maximum. It's actually maximum. Like when you find the the VDX from here is going to be 27 minus 3 all over 4 x squared. Okay? 3 over 4 x squared. Okay? That is, when you differentiate this one, you get 27. When you differentiate this, you use the 3 to multiply 1, that will be 3 all over 4. Then remove 1 from the power, and that's how we obtain that. Okay? So now this particular expression will now be equated to 0, right? To get the maximum. But how do you know it is maximum? The 2b the x squared. That's going to be minus 6 all over 4x, right? But when you substitute a value from here, which is equal to 0, if you equate this to 0, the value of x that you obtained here. So let's say we equate this to 0. What is x from here? 3 all over 4 x squared is equals to 27. X squared will be what? 4 times 27 all over 3. 3 in 27, that's 9. 9 times 4, 36. So x will be square root of 36, which is plus or minus 6. But since we are dealing with a real situation, so the domain of this particular expression does not go to the negative part because we don't have negative dimensions, right? So we only take the positive part of that solution, right? So x is of course equals to 6. So if x is now 6, if you put 6 here, whatever value of x you put here, this is going to be a negative, which shows it is maximum, right? Okay, so x is now equal to 6. So what is now the dimension of the rectangle of the box? So the dimension of the box is just the base, that is x times h. So that will be 6 times 6 times whatever. What is h? We know we have found h from here, so we have to substitute the 6 here to get to get um, to get h. So h from here is going to be 108 minus 6 squared all over 4 times 6. So from here, we are going to get 3, right? So h is equals to 3 here. And because it is 3 here, so this is going to be 6 times 6 times 3. So that will be the dimension of that particular box, right? So that will give us the maximum volume. Okay? So that's it.